This is an exciting morning. Did you guys just hear that? What are you doing to me, Zoom? What is happening? Okay. Does anyone, so let me try it again. Where does the line start? That's an interesting question. I mean, what's the starting point?
0 and -3.
Good. I was interested if anybody was like, what the hell are you talking about, Jeff? The line doesn't start somewhere. It goes forever in both directions. What are you talking about? But I consider that to be like a starting point. From there, how does it move?
Up 2 over 1.
Yeah. Up 2 over 1. So then it goes there. Up 2 over 1. Up 2 over 1. Right? And if my scale was better, it would be an actual straight line. That's not too bad. So I can graph a line without an XY table. I just need to know the slope and the y-intercept, or actually any point, but the y-intercept is where I can start, and then I move according to what this says. Why does it make sense that it's going up?
Because it's positive number.
Yeah, slope is positive. If it was negative, that would be like a decreasing profit. We would be worried. This is good for my business. Here's the profit, sir. Oh, right, Johnson. Good job. I don't know why it's always Johnson. All right. So now watch. Let's really analyze the hell out of this. I don't know if I've said this yet, but one reason, if I ask you, all right, let me try this. Look at this equation. Let's list a few answers. And we actually have a few answers here, don't we? Like 0, -3. Do you understand how an answer to this equation has to be a point? Because it has to have 2 parts because there's 2 variables. Is everybody with me? If I asked, there it is, Jeff. If I asked you to make a complete list of all the answers, why would that be an absolutely horrible thing for me to make you do? Let's get another answer here. Another answer looks to be 1, -1. Do you guys see that? 1, -1. Is that cool? And does that work? If I put a 1 in for x, I get 2 - 3, -1 comes out. Is anybody not with me right now? Am I still here? Yes, okay, thank you. All right. If the line goes through the point works in the equation. Right? Now that's come up a few times, but I really want to make a big deal out of it right now. If the line goes through the point, that means that that point works in the equation. That's what a line means. So if I had to list all the answers, how many answers are there? Don't say 4.
Infinity.
Infinite number of answers. So if somebody said list all the answers, I'm like, screw you. Here's all the answers. If I graph the line, it is you ready for this? It's a visual representation of all the answers to the equation. Because I'd much rather draw a line, bam, instead of make an infinite list. That might take a little while. This didn't take very long. You guys kind of with me? That is the most fundamental reason why we graph things. It's the quickest way to show all the answers. All right. Okay, moving on. So let me do this. Let's try this from a different place. Can somebody give me an answer to this equation?
Two plus 3.
2, 3, 11. Somebody give me another one.
4 + 1.
4, 1. It's crazy. Somebody give me another one. Oh, somebody else.
0 and 5?
Holy shit, yes. Now's your time to shine, people. Now's your time to shine. Give me another one. One more. Somebody else. Somebody else? Anybody? Is anybody else there? Is that all the people that are actually there?
How about 3, 2?
No
Switch
way.
it.
And then here's my answer. You ready? I'm going to give an answer. You ready? Here's my answer. What do you got, Jeff? 5.87 and negative 0.87. Yeah, Jeff, way to make that suck. All right. Right? Isn't that plus that 5? So, I mean, that's an example of how there's an infinite number of answers because, of course, we're going to go for the whole numbers. But then the line is like, I can work with freaky ass numbers too, right? Of course it can. Okay. Now watch. Somebody give me an answer to this. Somebody else that I haven't heard from yet. Linnell, I don't think you gave me one. Go ahead. Uh-oh. Are you frozen? Yes.
4 minus 1.
No. Well, I mean, 4 and 1. Do you guys see it?
Oh, yeah.
I like it. All right. Somebody else that I haven't heard from yet.
I didn't even know I was on speaker, Jeff.
All right. Somebody else. Anybody I haven't heard from yet? Somebody else tell me another answer. This is not difficult. This is your time to step up.
5 and 2.
No way. All right. All they need to do is subtract to be 3. Somebody else give me another one that I haven't heard from yet.
3, 0?
Yes, kick ass. All right. I'll stop. Can anybody, so how many answers are there to this? An infinite number. We just got started, right? How many answers are there to this? An infinite number. We just got started. Can anyone see if they share an answer? Is there something that answers both?
The 4, 1?
Yeah. 4, 1. 4, 1. So, all right. If I give you one thing that has 2 unknowns, if there are 2 things I don't know, there's an infinite number of possible answers. If you give me one more piece of information about them, I can figure out the answers. If there's 2 things I don't know, I need 2 pieces of information. So if I said 2 numbers add to 5 and they subtract to be 3, the only possible answer is 4 and 1. So now watch. Let's do this graphically because will the answer always be that quick to find? Do you always want to make a table of values to find the answer? No, we just got lucky, right? All right.
Run that back. Can you run that saying again? Say that again. So if you make sure I got it. You said it always end up being 4 and 1, but you need an extra amount of information.
If I only tell you, I've got 2 numbers in my hands and they add to be 5,
Right.
You have no idea. They could be anything as long as they add to be 5. If I tell you, oh yeah, they also subtract to be 3, then that could only be 4 and 1.
Right.
So I always look at this. What we're about to get into is called systems of equations. And I look at it like a murder case. So if you are the detective and you walk into this murder scene, how many things about the murder do you not know? A lot, right? A lot of things. So how much information do you need? At least as much information as the things you don't know. So mathematically, it works perfectly. If there are 2 variables, I need two pieces of information, which means two equations. If there were 3 variables, I need 3 equations. If there were 18 million variables, I need 18 million equations. It's crazy. All right, so now watch. Graphically, what would this look like? Let's graph these two equations on the same graph. Let me show you what's kind of wrong with the way this equation is to determine the slope and the y-intercept. Why can I not see it directly? What's wrong with this equation? What's the form of a line?
Y equals mx plus b.
So y has to be solved, right? I have to solve for y. So can you solve this for y, please? How do you solve this for y? How do you get y by itself?
Subtract the x.
Yes. Now watch how I'm going to write this. I'm going to shove the negative x in front. Why am I going to do that? So it matches up with mx plus b. Right? Just so I don't make a silly mistake. I have people that write it like this, and they think that's the slope because it comes first. But what's the slope? It's the number in front of the x. Do you guys see that? The slope is the number in front of the x. So if I put it in this order, if I put it in that order, I will make that mistake less, right? Hopefully never.
Would it work the other way though, or no?
It totally would. As long as you can identify the y-intercept and the slope, you're fine. But like I said, if people write it like this, very often they'll think that's the slope because it's the first number they see, but that's not what this says. The slope is the number in front of the x, period. So no matter which way you write it, what's the slope? What's the slope? Oh, there you go.
Negative?
Chat. I didn't even have my chat going. I'm sorry. Yeah. What's understood to be, not just negative, but what's understood to be there. Right? That poor little one dude never gets to show up. Almost never gets to show up. Poor little dude. We're just like, we know you're there. We understand you're there. Little one dude's like, All right. Is everybody with me? And what's the y-intercept?
0, 5.
0, 5. Kick ass. What about this dude? I want to show you a little trick. You ready? Do you see how the y is negative? That kind of sucks. I don't want the y to be negative, right? So what I do is I add y and subtract 3. So I get y equals x minus 3. If you don't like that, if you don't like what I just did, you got to be careful when you solve this. If you subtract x, the negative is still there. You have to divide by -1. And then you get y equals positive x minus 3, like I just did there. You guys with me? Be a little careful when you're solving.
Can you do that one more time?
This one down here?
The top one.
Oh, the top one. Okay. All right. All right. Now, this is a really cool. Here's the real shortcut. You ready? If I add y to both sides and I subtract 3 from both sides, do you see how they just switch places? If I subtract 3, those cancel. And if I add y, those cancel. So let me do it better. Sorry. This is not a big deal, but it is a very useful shortcut. So if I add y and subtract 3, you see how the y and the 3 just switched places? Cool, I like it. So if I had 7 minus x equals 5, I would add x and subtract 5, so it'd be 7 minus 5 equals x, so x is 2. Bam! It's a really useful shortcut. Do you have to use a shortcut? No. I just showed you how to do it a different way. Okay. All right, let me make some room here. Somebody got that one way or the other? Let's put it back up here. So what's the slope here?
1.
1. I like it. And what's the y-intercept?
0, -3.
Kick ass. All right, so now, if we graph, ooh, hot pink. Let me see, what do I have here? Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not bad, Jeff. This is exciting, Jeff. I know. All right, that's enough. So let me graph. Oh, this is perfect. I'm going to graph this one in black and this one in purple. I have no idea if, I don't think you guys can tell the difference. Oh, well. So this guy has a y-intercept of 0, 5. And then the slope tells me to do what? What's a better way to write that slope? So how do I move from here according to the slope? What do I do? What's it mean when the rise is negative? That means I actually
Go down 1 over
fall.
1.
Fall 1, run 1. Fall 1, run 1. Fall 1, run 1. That sounds like red rum. Fall 1, run, run. Run, run, fall 1. Run, run. Okay. That's probably enough. So I do several steps. You're going to see why in a minute. But that's really nice for one reason is this maybe helps me draw a straight line better. All right. Make those big. There we go. Now, on top of that, graph this. Maybe I'll do it in blue. Yeah, okay. So where do I start for this line? Where do I start? What do I plot first?
At the y-intercept.
Yes. So it's going to be right there. And then from there, I go what?
Up 1 over 1.
Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay. So visually, where's the answer? If all the blue stuff is all the points that work in this line, and all the black points, all the black line stuff is all the points that work in this line, which point works in both lines? The point where they
1, 4.
careful.
Where they intersect.
Where they intersect. You had it backwards.
Oh.
4, 1.
4, 1.
Which, remember, isn't that the answer we got earlier by observation? Remember that? We saw that. Okay, so if you graph the lines, it's easier to find the point. You don't have to kind of hope you get lucky by making a big ass table of values. So this is beautiful. If I graph a line and it represents all the things that work in that equation, and then I graph another one and that represents all the things that work in that equation, then where they meet is what works in both equations. Okay, all right. All right, so I'm going to try to give you a problem to try on your own. Here we go. Here we go. Is anybody still copying that? You guys all got that? Okay, it's going to go away. So let's see. Graph both lines. Determine a solution. Let's make this a little more interesting. Yeah, Jeff, that's gross. I like it. All right. Oh, shit, I got to make this actually work. All right, give me a minute, guys. Wouldn't that be nice? Do you want one that works? Yeah, okay. All right, I got it. Oh, that's not going to work. Hold on. Yeah. This is exciting. Okay, I think this will work. I'm pretty sure that'll work. Yes, it will work. Okay, good. It's actually, I hope you guys realize this. This is interesting. It's actually better when the slope is a fraction, because then you don't forget to put the 1 in. You already have the rise and the run. See, that's the one situation where a fraction is actually better. I don't know if you guys agree with me, but it's the truth, so you should. Okay. So graph this line on a graph this line on the same graph, and then see where the answer is. I'll just stand here. Maybe I'll make the poor little 3 dude. There you go. All right, guys, let me catch up to you. Is everybody good with what I got up here?
Yes.
All right, so just identify the slope and the y-intercept. So starts at 0, -1, this guy does. And it will rise 3, 1, 2, 3, and run 2, 1, 2. Rise 3, 1, 2, 3, and run 2. Where am I at? Oh, yeah. This one starts at 3. We do this in red. Oh, shit. Maybe I should make this line. This one starts at 3. And then it falls 1 and runs 2. Fall 1, run 2. Fall 1, run 2. All right. so what's the answer?
2, 2.
2, 2. I love it. How do you check that?
Plug it in.
Plug it in, yeah. So if we plug a 2 in here, it cancels with that 2. 3 minus 1 is 2. If I plug a 2 in here, it cancels with that 2. Negative 1 plus 3 is 2. You can always check your work, right? So something that this would lead to is if I had a country here and they shot a missile at this other country here, there's an equation that describes this missile's motion, right? There's an equation that describes this motion. So I want to figure out what equation my interceptor missile has to follow so they meet and it kills the other missile. You guys kind of with me? Obviously, those equations are a little more complicated. Plus, they are in 3 dimensions instead of 2. But the basic idea is the same. I want them to meet so that I can destroy that missile coming at me, right? Okay, maybe. All right. Let's see. Yeah, let's go in the book and see what kind of freaky stuff they do with this. Oh. Let me move you guys over there. All right. Part of me wishes when I move the whole window, everybody gets shaken around or something. Whoa, Jeff, stop it. All right. Let me see where I want to go here. Let's just look right at the homework. Why not? Why not? All right. So I have no idea if anybody can relate to this about diapers. So some of this is going to be dealing with putting together equations from information. So that's something we've done already. This first one actually talks about unit price. Does anyone know what unit price is?
How much each diaper costs?
Yeah, so for example, how would you figure out the unit price for Amazon's diapers?
You divide.
Yeah, so 234. Well, it would be 46.99 divided by 234, to be honest. Because then you could see how much money it is for one diaper. You guys with me? So unit price is price divided by the number of units. You guys with me? Anybody ever go grocery shopping? And they have the family size cereal, but if you look at the price per ounce, it's actually more expensive than the smaller box. Has anyone ever seen that? Anybody?
Yeah.
Yeah. So I'm like, what are you trying to pull here? Jeez. So then I just buy 2 boxes of the smaller one. Screw the bigger one. I thought the bigger one should be better. So you got to be real careful. I mean, it's a lot of places list the unit price now, or the price per ounce, or the price per whatever. In this case, we're doing price per diaper. All right. So if you do it for both of them, you can see which one is the better deal. I like this. They're bringing back a lot of stuff. And then they finally get to an equation down here. I love it. Kick ass. Then they got a table of values. All right. Where do you actually get to graph anything? Anywhere? No. Well, dadgummit. All right, that's fine. So they're going to do it with tables instead of with graphs. That's fine. Yeah, so right here in an earlier problem, the point where the graphs cross is where the 2 heights are the same. So that's what we were doing up here on the board, is if I graph both lines, I can see where they meet, and that's the solution. And just to remind you guys, like I said, this whole thing is about systems of equations. I like it. Now let me check one thing here. Let me make sure if they're doing this a different way here. I don't think so. Blah, 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 blah. Oh. Okay. Here we go. This is beautiful. This is beautiful. Okay, beautiful. I'm so happy. All right. So last thing I think for today, I want to show you something I didn't think they'd get into, which is awesome they do. Do you think why was this answer easy to get graphically? Because the answer was whole numbers. What if I had a system of equations where the answer was something like 1.9837, comma, 2.0764? Am I going to get that from a handmade graph? Do you think?
No.
My sucky graphs, I can almost not get whole number answers with my horrible scale, right? Ain't no way in hell I'm going to graph and get 1.987, blah, blah, blah. So what does that mean, Jeff? That means that there must be an algebraic way to do these problems. And there totally is. Here we go. So what I mean by that is, watch this. This is kind of neat. So what if I had a system of equations? System of equations that look like this. What do you got, Jeff? Let's do, 4x minus 3y equals 2. And let's say x equals, 2y. I like it. All right, so these two things are pieces of information that I know are true. Is everybody with me? Those are given to me. Those are true statements. So can somebody tell me what x is?
2y.
Yes, kick ass. I love it. So other people out there might be like, how the hell do I know what number x is? I didn't ask for a number. So don't I know x is 2y? Don't I know that? They told me that, right? It's like, this guy is twice as old as this other dude. All right, let me write that down, right? So I know that's true. So how can I rewrite this first equation using that information? I know that x is 2y. So if I start to write this equation, 4 times x, but what is x?
2y.
2y, that's right. Let me make sure you guys, do you understand how I just rewrote this, didn't I? 4 times x minus 3y is 2. 4 times x minus 3y is 2. But what did I put here? I put what x is. Not surprisingly, this is called the substitution method. Become a D. I substituted x with 2y. Now, why is that equation better than the other two I had? Why is this equation better?
More straightforward.
How do you mean?
I don't have to replace stuff in my head.
Okay, I'm with you, but what sucks about these two equations? How many unknowns do they have?
2.
Two things. The number of unknowns is too damn high in these two equations. If I write this one, there's only one unknown. Can you solve for y? Yeah, what's 4 times 2y? It's 8y. You're going to love this. You ready? 8y minus 3y is 5y. So what's y?
-3.
No, careful. No, no, no. Come on. What do you have to do to both sides to count to 5?
Take the one, the
I know you're really happy to see that happen. You're like, oh, good, Jeff. But again, if I tried to graph these two equations, I would never get that. Are you kidding me? If I try to graph it and do the slope, I'm never going to get that answer. That's too precise. Do you understand what I'm saying? Anybody? I'm not going to get that by graphing things and going, where does it look like? Holy shit, I don't know. It's not a perfect whole number. I would have to guess. I couldn't get the answer exactly. There's no freaking way in hell. I can handle whole numbers. I can't handle 2/5. Are you kidding me? Now, am I done with this problem?
No.
No, because how many variables are there?
2.
2. And how many do I know right now?
1.
1. Okay, so how do I figure out what x is? Well, x is twice y. And what's y?
2/5.
2/5. There you go. 2/5, Jeff. So what's 2 times 2/5? It'll be 4/5. So what's my answer? My answer is 4/5, 2/5. That sounds like a weird Dr. Seuss book. 4/5, 2/5. Red fish, red fifths, blue fifths. Take a shot of a fifth. I don't know. Whatever gets you through. That's a different kind of Dr. Seuss. He was going through a rough time. All right. So I'm going to let you guys try a problem like this, and then we'll call it a day because I need to sit down and see if there's any new information.
Just go Georgia.
Huh? What? What?
We need Georgia. Right? You know?
Georgia, I'm hoping. Oh, boy. I really would. It would be nice if we can get Georgia. Oh, boy. We can win without Pennsylvania, to be honest, which is surprising to me, but we actually. Anyway, sorry. And I keep saying we, and I might not include you, and I'm sorry. I don't want to make anybody feel uncomfortable. We'll stop. Okay. So let me create a problem for you. It's fun to have a job where your job is to create problems for people. I get paid for that shit. All right. So solve this system of equations. What do you got, Jim? Let's do. All right, let's see. Yeah, let's do this. I like it. Sure, I like it. I like it. That's not too evil and not too simple. I love it. right? I got a bit of a game plan here, right? What is my? Sorry, all right. So I can write 4x minus twice y, 3, but what's y?
5x.
5x. So I used this information together with this information. So it's a lot like a murder case. I love it. So you're telling me that you were at the grocery store and you saw him at the grocery store. Okay, that's, you know, I can put together two separate pieces of information. That's exactly what we're doing here. So then I get 4x minus 10x negative 6x negative 1/2. Okay. How's everybody doing there? Let me stop for a minute. Is everybody all right with that? Anybody not okay with that so far?
Okay, I was looking how you dropped from there. Okay, yeah, I can see your 2 times 5 came down with a 10 here, right?
Yeah. And so negative
And
2
then you
times
rewrote it here again, and then so you got rid of the 6s, canceled out, and then that's a half, yeah.
negative. How do I get what y is? To be really honest, you could plug this into either one of these, right? Do you understand that? Because it's where the lines meet, so it should work in either line. But which line would I rather use? Which equation?
First one.
Hell yeah, because it's already solved for y, right?
Mhm.
If I plug this information into here, what's 5 times negative 1/2?
Negative 5. Oh, wait.
I pretend like you said this. All right. So then your answer, now, if you leave it like this, I'm okay. But I like it if you put the answer as a point, because the answer to a system of equations is always the point where these would meet. So if I did graph these, they would meet here. And again, that's another point that I would probably not be able to get, especially with my horrible scale that I make. So thankfully, there's an algebraic way to do it. Algebra saving our ass again. That's all it ever does. Is try to save your ass. All right. And we all hate the poor guy. Just trying to do his job. Leave it alone. All right. I think that
If we leave the 3 over negative 6, I know it has to be reduced, but I didn't reduce it on my paper. Would it be incorrect?
technically, yes. It's the right number. It's just a convention that we reduce things. So if you don't reduce, you're not going to lose like a ton of points, but you're going to lose something.
So always reduce.
Always reduce at the end of a problem, yes. If you can, yeah. All right. But again, I mean, if you didn't reduce, I take a point off or whatever, some small amount. It's something you're supposed to do, but you're technically right. Because 3 divided by negative 6 and negative 1 divided by 2, they're both negative 0.5. So mathematically, they're both the same number. It's just convention to write it in lowest terms. Any other questions, guys? All right, that's enough. That's enough for today. I'm going to call it. Don't forget, we have tomorrow off. You're welcome. Jeff is going to be at some big.
Yay.
Yeah. You guys do something that's more fun than being at some big ass meeting. So that'll be.
Yeah, did you have your office hours yesterday?
Did you not get my email? I got it. I got a message saying that you were waiting for the class link. There is a office hour link in Canvas that you're supposed to click if you want to come to office hour. Yeah. So I tried to send you an email saying, hey, I just got a message saying you're waiting in the wrong place.
Yeah, I was trying. I was like, where's Jeff at, man? What's up?
Here,
Okay, cool. I had to get at you.
Remember what I'm talking about?
Wow.
If you go to the modules, it's that first module. It's got the office hours links. So there's a Tuesday office hour link and a Thursday office hour link. It just makes it easier on my end.
Yeah, I actually went from the email.
The email. All right. Okay. I don't know.
And then you got the announcements up. But anyway, yeah, I hit the wrong one, I guess.
The announcements are always the class link.
It's the class, not the office hours. Huh?
The office hours are in the module. Yeah.
They're in the modules. Okay.
Yeah. Sorry, man.
Wow.
I'm trying to figure out the best way to do this. Anybody else have any more questions? You guys all right?
Yeah, my question is old, but I'm gonna leave that alone.
Okay.
One about old. I'm gonna
Up to
let you go ahead. Huh?
I said it's up to you.
Okay, who was it at? A homework question I was tripping on. It's out of 2-5. I mean 3-5.
3-5. Okay. So which one we're looking at?
Brain lock on how to start that off, like how to find that out.
Which one? Sorry.
Let me get there.
Oh yeah.
Yeah, about the speed limit and the 15 miles per hour.
Mm-hmm.
Number one. Yeah.
Yes. Yes.
So I got brain locked on how to figure out the actual mile an hour, like they were traveling. They were traveling 15 miles per hour.
No. So the usual speed is 39 miles in 45 minutes, right?
Right.
So one way you can do this, and I don't want miles per minute, do I? I want miles per hour, right? Like a normal human being, right? So
Right.
what do I know? Oh yeah, I gotta plug this thing in.
Bluetooth mode.
Yeah. Is it connected?
Bluetooth connected.
Thank you. So 39 miles in 45 minutes, but do I want minutes down here?
No, you on hours.
So I can put minutes up here, hours down here, 1 hour to 60 minutes. And then you can figure out miles per hour.
Okay.
So the usual speed has nothing to do with the 15. 15 is how it changed. Here's what they usually do, right? Usually takes 45 minutes to go 39 miles.
Mm-hmm. But now they're going a little slower.
Yeah, so number 3, the first thing you do is you take this speed and you subtract 15.
Mm-hmm.
I like it. And then you can figure out how much time it's going to take. So on this one, it's going to be, whatever you get here, it'll be 15 mile an hour less than that. And you want to go 39 miles, and they want to know how long it's going to take you.
Mm-hmm.
Okay.
Okay.
And don't forget, this could help. Distance equals rate times time, right? That old equation, dirt, that can help you. Okay.
Okay.
That should be enough to get started with, right?
Yeah. Got to give
Okay.
me a kickoff.
Yeah, exactly.
All right. Don't stress too much, Jeff.
We'll
You got a
find
long
out.
weekend ahead of you.
I mean, I got 4 years to stress out if it goes the wrong way, right? I could spread it out over 4 years. I could
Yeah,
see
you
if
can
I
spread it out much for you.
yeah,
That helps.
yeah,
That helps. Can't eat the elephant in one bite.
exactly.
All
Let's
right.
see. You guys all right out there? All right, I'm gonna head out. I don't see any more questions. I'm out of here.
All
See you
right.
guys.
Peace.